So to get the area region bounded by the grass, we need a couple things here. We need the bounds because ultimately we're going to integrate, right? And then we need a lower bound and an upper bound for x that covers the region. The function that represents the area between the two curves, and then we do a definite integral. All right, so let's do that before we tackle the algebra here. If I were to graph these, it might help to graph them. You might be able to kind of visualize what's going on here. Y equals 0 is the x-axis. So this curve, if it's above the x-axis up here, then it's just going to be integrated from this curve, whatever it looks like, to y equals 0. And then where does it intersect the y-axis, or the x-axis rather, is kind of where my bounds will be. Okay, so the best thing to do is probably to graph it. You could run this through, and here's the algebra piece: x to the 1/2, 1 minus x, that's x to the 1/2 minus x to the 3/2. And I mean, you could do this algebraically, or you could look at a quick graph of it, which is probably what I would do on a homework. There could be you could be asked to do this algebraically. Algebraically, you kind of want to know when it crosses this axis so you can set it to 0. Let's see if we can do it this way. Graphing would be easy. Just plug it into Desmos and then draw a picture of the graph. And then that's going to help you with whatever these x values are, right? That'll go here and here. Or I could do it this way. What would I do with this one? Now I'm going to go backwards here. All right, this is just finding the intercept. So it hits at x equals 0. We got an intercept there. And it hits at x equals 1. We got an intercept there. And then my guess is it's above the x-axis, just because it's a find the area of the curve problem. But you could kind of like plug in x equals 1/2 to see what happens. I mean, most likely it's up here. Okay, so with a little bit of investigation, you can figure out that that's the area you're looking for. And you're going from 0 to 1 based on solving this equation. I know I just went backwards. I put it right back into this spot. But when I integrate, I want to use this form of it. So that's x to the 1/2 minus x to the 3/2. And then from there, I integrate. So that's going to be, we use our power rule, add 1, divide by the new power, add 1, divide by the new power, and then integrate. Okay, so whatever that is, well, we might as well finish it because that's pretty easy. You know, when you plug in 0 to that, you're going to get 0. So you plug in the 1 first, so it's 2/3 times 1 minus 2/5 times 1 minus, and then we would have to plug in a 0, but you're just going to get zeros there. So your answer would be 2/3 minus 4/5, which is 10/15 minus 6/15, which would give you 4/15, which is this area in square units. Okay, so that's how you do the whole problem. The idea here, the area between two curves idea is find the area between this curve. They're giving you two curves, right? There's one curve, that's the real curve, and the other curve is just the x-axis. I mean, this could be y equals x, or you can have and then you try and figure it out the area between those two different curves. But in this case, they're just giving you the x-axis there. So I hope that makes sense. Let me know if you have more questions.